This is a screencast for 2.4, vertical angles. So vertical angles are two non-adjacent angles whose sides are formed by intersecting lines. So here's one line, here's my other line, and so I could have two sets of vertical angles. I have this set that's across from each other, and then I have this set in green that's across from each other. So if I would label each of these angles, like I could name this angle 1, angle 2, angle 3, and angle 4. Angle 2 and angle 4 are vertical angles. And we also could say angle 1 and angle 3 are vertical angles. Now, a linear pair are two adjacent angles whose non-common sides are on the same line. So for angle 5, this angle right here, the non-common side is this one. Then I look at angle 6, well, the side that's not in common with angle 5 is the bottom one once again. So these two non-common sides are on the same line. So linear pair have to be next to each other. They have to be adjacent. Okay, so we want to determine whether each labeled pair of vertical angles is linear pair or neither. So this is going to be a linear pair because I have two angles that are next to each other, they're adjacent, and their non-common sides form a line. Now the issue with 3 and 4 is if I extend this line out, like why is this line all crooked, right? This is not okay. We have to have lines. If I would draw this out, this is just segment. So I can't say they're vertical angles. So these are going to be neither. And the reason is because vertical angles have to lie on, vertical angles have to have two lines and they must be across from each other. Now, 3 and 4 were across from each other, but they have to be across each other from two intersecting lines. Now the issue is this line right here, this part right here, this segment, it's not straight, so I can't say that is a pair of vertical angles. These are vertical angles. All right, postulate 7, linear pair postulate. So if two angles form a linear pair, then they're going to be supplementary, and that's because they're going to add to 180 degrees. So remember, if we would go all the way over, we would have what is called a straight angle. So it would be 180 degrees. So I can say the measure of angle 1 plus the measure of angle 2, these two angles together must sum to 180. So linear pairs are supplementary. That means they add to 180. It does not mean that all things that add to 180 are linear pair. No, because linear pair has to be adjacent, and then we say, okay, well, they form a line, so they're going to be supplementary. Find the measure of angle RSU. RSU is going to be this angle. Okay, well, it looks like to me that the total angle is 180. So this angle RSU plus, right, if I take the measure of RSU plus 62 degrees, it's going to equal 180. All right, let's slow it down for a moment. So if I have the measure of angle RSU and I add the measure of angle TSU, together they're going to be 180 because I have a linear pair, and linear pairs are supplementary. All right, so let's go ahead and let's plug in for the thing that we know. So the measure of TSU is 62 degrees. So if I subtract 62 degrees on both sides, I get the measure of angle RSU is going to be 118 degrees. All right, vertical angle theorem. If two angles are vertical angles, then they're going to be congruent. So as long as I have two angles across from each other, when I have two intersecting lines, they're going to be congruent. So I can say angle 1 and angle 3 are congruent, right? Angle 1 is congruent to angle 3. And then I can say angle 2 and angle 4 are congruent. Now the reason I use a single line versus a double line is if I'd use a single line for 2 and 4, then that would also mean they're congruent to 1 and 3, but that's not necessarily true. I only want to show that the ones across from each other are congruent. So that's why I could use the single line and the double to tell the difference. I could have a single line or a double through there. So if I would redraw this, I could have a single line, single, and over here I could have the 2. It just depends how your book does it. And different things you find online will show it different ways. All right, find the measure of angle CED. CE D. Okay, that's this angle here. Oh, okay, so it's a vertical angle. These two are vertical angles, so therefore they're going to be equal. So the measure of CED is going to be 50 degrees. So CED is 50 degrees. Find the measure of angle 1, angle 2, and angle 3. Okay, so first I see angle 2 is a vertical angle, so it's going to be the same as the 35. And then if I would add 35 degrees plus the measure of angle 1, I know it's going to be 180 because they are a linear pair. So subtract 35 degrees on both sides, and we get the measure of angle 1 is equal to 145 degrees. And because angle 1 is 145 degrees, means angle 3 is going to be the same because these are a vertical pair. Vertical angle pair. All right, I'm going to start with angle 1 this time. I know if I would add both of these together, 28 plus 1, 28 degrees plus the measure of angle 1, it's going to equal 180. So if I subtract 28 degrees from both sides, I get the measure of angle 1 is 152 degrees. Okay, so that's like the hardest one to figure out. If angle 1 is 152 degrees, so this angle here, that means the vertical angle must be 152 degrees as well. And then since we're on the topic of vertical angles, 28 degrees and angle 2 must be a vertical angle pair, so that's 28 degrees. Last one, this angle 67 and 2 are a vertical angle. And if I would add these two angles together, 67 degrees plus the measure of angle 1 has to be 180 because they are a linear pair. So we're using vertical angles, pairs, and linear pairs. Subtract 67 from both sides, and the measure of angle 1 is going to be 113 degrees. And if the measure of angle 1 is 113, that means the measure of angle 3 is 113 as well, because those are a vertical angle pair. All right, find the value of each variable. Ooh, here we have a vertical angle pair. So they're vertical angle pair, which means they are congruent. So I set 4y minus 42 equal to 2y. Subtract 4y from both sides. I get negative 42 equals negative 2y. Divide by negative 2 on both sides. We get 21 is equal to y. If I try the next one, part B, once again, these are a vertical angle pair, so I can set them equal. So I have 89 is equal to 2r plus 3. So I subtract 3 from both sides. 86 is equal to 2r. Divide by 2, we get r is equal to 43. Because first thing I did was I looked at these and I said they're a vertical pair. Let's look at C. C is also going to be a vertical pair. They are across each other. They're across from each other with two intersecting lines. So they're a vertical pair. So I can set 3x equal to 2x plus 16. Subtract 2x from both sides, and I get 16 is equal to x. Okay, this should say x. And then lastly, ooh, we got a little complacent. This is a linear pair. Okay, so you got to watch out. Are we across from each other, or are we adjacent, forming out a 180-degree angle? So I know together, the first angle, 20t plus 5, plus my other angle, 15t, has to equal 180 degrees. They're a linear pair. Combine like terms, so 20t plus 15 is 35. Subtract 5 from both sides, I get 35t is 175. And then when we divide by 35 on both sides, we get t is equal to 5. So it should say t, not r. Got a little copy paste happy. Okay. Last part, algebra review. Definitely come to bonus if you need more help doing this. We want to move everything with a variable on one side and everything without a variable to the other. So first step, I'm just going to move everything to the left. That way I have a positive coefficient in front of a. Okay, then I'm going to rewrite everything I just had. Oops, okay. So this is minus 10, 15. Okay, so add 10 on both sides. I'm good now, right? I moved everything with a variable to the left, everything without a variable to the right. So if I divide by 2 on both sides, I get a is 12.5. You could also write 25 over 2, right? Fraction is fine, decimal is fine, either way. And then part 3, I need to distribute this out. So I have negative 6x plus 2 plus 5 is equal to 6, and then distribute the negative. Minus 5x. Let's see, was this a minus or a plus? Okay, so minus 7. Combine like terms. So negative 6x plus 7. Combine like terms. 6 minus 7 is negative 1. Add 1 on both sides. So I have 6x plus 8 is equal to negative 5x. Add 6x on both sides, and I get 8 is equal to x. 8 is equal to x.